Okay. Welcome back, everyone. It is past 11, and we're ready to start the next session. The first part of the session is going to be a real treat for everyone interested in routing security. And to kick things off, my wonderful colleague, Misha, is going to introduce ASPA, the latest addition in the RPKI ecosystem. Misha is going to introduce the concept as well as the practical ways to implement it. So please take it away.
Good morning, everyone. I'm Mikhail Puzanov. I work for IPNCC, and for the last 10 years or so, I'm working mainly on RPKI related infrastructure and implementations and whatever else we do there. And yeah, this talk is going to be about what's called ASPA or ASPA, but kind of ASPA stuck in a way, similar to ROAS. And yeah, it's going to be about what it is in principle, why would you need it, what do we do about it, and the more or less some initial sort of some preliminary results of what comes out of it. Yeah, so first of all, what is it? ASPA stands for IS Provider Authorization. So it is part of the RPKI ecosystem, similar to ROAS, which stands for Route Origin Authorization. And it's a relatively simple data structure, which is signed by the owner of the customer AS. And the owner of the customer AS is supposed to authorize a bunch of provider ASs as their providers. So basically you say, these guys are my providers, and this is the sort of a cryptographic rubber stamp on this fact. With one exception, that you cannot be a provider to yourself, because that creates like weird corner cases, which we don't want to have. And so the reason for this thing to exist is to verify the AS to AS hops, and in general validate the AS path. And every AS to AS hop verified with a bunch of ASPA objects that are relevant to it can result in the status of provider, a not a provider, or no attestation, which means we don't know. And more general, a path received from a customer by any upstream network is considered invalid if there's any not provider status on the path before that. So, and this AS path is not supposed to be learned for any further routing, and yeah, generally not used. I will talk a bit more later. What does it mean not used? And the reason for it to be designed this way is to have partial gradual deployment similar to ROAS, where of course we cannot have like a kind of a big bang deployment. And it also the infrastructure that is supposed to fail open in case the whole RPKI validation is somehow broken. So if there is, I don't know, RPKI validators are broken, repositories are not available, what else is there? The whole situation basically just falls back to what it was before. Yeah, and now there's going to be a bunch of examples with the pictures and all that, just to illustrate what kind of results we expect from ASPA verification applied to, well, slightly cartoonish, but hopefully more or less realistic routes. So the most obvious reason to have these things is to prevent AS path spoofing. So in this picture, you can see that there's a well, the green arrow is the actual ASPA authorization. So there is a AS2, which is a provider for AS4. And there's even a row existing for AS4 and the prefix. And then you have on the right this evil guy that pretends to be AS4, but they are not. And how the ASPA helps in this case is that, let's say AS1 sees the AS path consisting of like 1, 3, 5, and 4, and we only are aware of AS2 being provided for AS4, which means that this path of 1, 3, 5, 4 will be rejected as invalid. The same applies to root leaks, essentially. So it doesn't matter if you spoof stuff or if you're just leaking, the same story will happen. So AS1 will see a path 1, 3, 5, 4, which is not supposed to be happening based on only one ASPA object existing between 4 and 2. So in this AS path was going to be rejected as invalid as well. Yeah, one of the sort of advantages that were kept in mind when designing these objects is to prevent valleys in routing. So yeah, I guess I'm not a network engineer, so you probably know better, but nevertheless, a valley in the routing is considered is a network that is in AS path, where we go from a customer upstream to provider, and then back from provider to a customer, and then up again. And this sort of a middle bottom is called valley. And there is tons of research, and there is tons of practical considerations why these valleys are considered very harmful. There's a traffic congestion, there's a very bad impact on latency, it's economically not very smart to be this guy in the middle, and data security is suffering in this case, etc., etc. So these things are supposed to be filtered out somehow. And ASPA can help with that, and the verification algorithm that is there now is actually supposed to filter out these situations. And it works. In general, it basically takes any AS path. It goes from one end on the ramp up from customers to providers. It goes on the other end from customers to providers. And these two ends either supposed to meet in the middle, or there should be not more than one hop between them. And if there's more than one hop between them, that's considered to be a valley, and this path will be rejected in a nutshell. Let me go to the next one. Yeah, and the more cartoonish examples, in this case, everything looks nice, and this is a valley-free situation, and you see the green arrows are, again, these are hops authorized by ASPA. So we have AS2 being a provider for AS5, AS1 being a provider for 2, and for 4 as well. So we have these 3 ASPA objects. And yeah, considering the AS path, pretty much any of them, but let's say a route from 5 to 4, this algorithm of going ramp up and ramp down, they will meet in the middle at 1. And yeah, that's a valid situation, no valleys. The same applies to this case with peering between AS2 and AS3. With the only difference that, again, if we go up, if we go and ramp up from 5 to 2, from 6 to 3, they don't meet in the middle, but there's one hop between them, which is considered to be a valid situation according to this verification algorithm that is developed for ASPA. And this is an example of where it is not nice. And the S3 is going to be a valley with exactly the same, with this algorithm that I just mentioned, because again, going ramp up from 5 to 2, from 4 to 1, and then between 2 and 1, there's extra hop in to extra network AS3, and that is considered to be a valley, and that path is going to be rejected by the verification algorithm. Yeah, AS0 is a special case, and in ASPA it is used. It can be used in the provider list to indicate that this customer doesn't have any providers. There's the extra requirement, which is the most recent change in the RFC draft, that basically says that if you use AS0, sorry, in the providers list, you shouldn't use anything else, because, well, you either don't have providers or you have them, so yeah, you're not supposed to say both of these things. It cannot be on the path, basically any AS that goes after it on the path will have the ASPA verification status no provider, so it was going to be considered invalid. So that should be used by tier 1 networks, root servers that don't put themselves on the AS path, so transparent, root collectors, I don't know, whatever else, other probably BGP speakers that, yeah, that might need it in the future. Yeah, that's the same example as the previous one, essentially with the valley, with the only extra addition here is that AS1 is claiming to not have any providers. So we are kind of limited by, that fact limits, you know, all the sets of all possible AS paths that are possible here. So, but the logic here applies exactly the same. We will detect the valley by going from both ends and seeing that there's 2 hops between these pieces of the path that we found. Yeah, and yet another example here, which is might be a little bit more realistic looking, with, you know, green arrows again. So you have all indicating the existing ASPA objects, and the logic here will be exactly the same. So if we see a S path between these 2 different ends, left and right, so between 6 and 7, the same algorithm going from one end and from the other will not meet in the middle and will not reach the adjacent ASs. It will find that AS4 is a valley and reject this path. Yeah, of course, for that to work, you need support of this technology in routers. In principle, it is exactly the same deployment model as with ROAS. So you have RPKI CAs that generate this ASPA object, that assign them, publish them into RPKI repositories, RPKI validators installed on-premise. They download these repositories, validate everything, and then push the actual payload of these objects to routers. So routers don't do any crypto. It's a very simple protocol, the RTR. So currently, ASPA is included in the RTR protocol version 2, I believe. So there is 0, 1, and 2. And this version is very close to be published as RFC. There's some like grammatical, I think, cleanup is happening and that sort of stuff. Unless I missed something, and it's probably already published. So it's ready. And most of the RPKI validators do support it. Yeah, when it comes to deployments, In principle, similar to route origin validation. In some ideal world, a network are supposed to reject invalids. So not just down preference them, but reject. But since it's just sort of the very beginning, it's probably not very smart to just reject that. And it's probably better to just start logging these cases and talk to other networks who happen to publish things that are being rejected by ASPA verification. And another thing here is that there's actually not that many routers that do support it. So with the software routers, it's easier. So it's supported on a bunch of the software routers. Probably this list is longer already by now because it's a pretty quickly changing environment. And the Cisco is testing the implementation as well. So for now, yeah, logging and measuring and keeping track of that and figuring out why some of the cases are rejected would probably be better. Okay, so what should go on these objects? Obviously, all your transit providers, everybody is on upstream. Not lateral peers, unless they can be providers as well. And route servers, if they add themselves on the AS path, so they need to be there as well, but that's, I guess that's a pretty rare situation. What it gives is, first of all, protecting from leaks, protecting from past spoofing. That's the most direct intention of these objects. But the other thing, which is probably even more important, is that you protect other networks as well. So similar to route origin validation, that sort of creates, let's say, a collective immunity of a sort. So you don't even have to have full deployment everywhere to be able to reject the majority of potential hijacks and leaks. So yeah, you should not do that if you don't know who your providers are by some reason. Because if you create an ASPA object with the incomplete list of providers, the ones that are not mentioned there will be rejected from now on. So that's going to be pretty serious shooting yourself in the foot. So if you're not sure, then don't. And another thing is it's, of course, it's important to keep these objects in sync with your actual operations, because if that's not, again, you will come to the same situation of invalidating your own actually used routes. Since half a year ago, I believe, November last year, we have ASPA support in the RPKI dashboard and RIPE-NCC. Yeah, there's just one screenshot here because it's that simple. It's a very simple data structure. There are some UI bells and whistles there, but in principle, we know your customer as, so you can just choose from the list of your customer as and add the providers. So that's pretty much it. And the rest is happening on the back end, so it will generate everything and keep all the objects up to date and rotate them, etc., etc. Another feature in the dashboard that is we were scratching our heads about, and that is not there, is something similar to what happens to RAWs, because for RAWs, we can just say, these are your announcements, we know about them, so you probably just want to cover them with RAWs. In this case, it's much harder to do it for ASPAs. It's easy to create false positive. It's, you know, people forget things, and it's probably going to do more harm than good. But we might settle somewhere in the middle where we just suggest networks that you have probably forgotten that guy. So we know for sure that there should be a relationship, but there if the user is not creating it, probably it's forgotten. So we will look at it later this year. But so far this feature is not there. But if you do have a suggestion on that, yeah, it would be interesting to hear what you think about it. Yeah, so what we have with that, with all ASPA uptake, it actually goes pretty rapidly. So you see that the two graphs here, RIPE-NCC and ARIN, are going up really rapidly. That has to do probably with the November last year UI added for ASPA in RIPE-NCC and UI added for ASPA in January. So apparently people like doing that through the UI still. And even though the API support was there for much longer, nevertheless. So it's about 1,600 of these objects floating around already. Yeah, and this is the uptake in the region. So these are just percentages of how many customer ASs are covered by ASPA object compared to the total number of AS numbers per country. So there's definitely just the very beginning of it, and there should be much more, of course, to have a significant impact. But it goes pretty quickly, so we'll see. Yeah, and just curious statistics, there's more than 40 objects with no providers. So about 44 networks a week ago saying that they don't have providers, which makes sense. Yeah, so what do we do next about it? So there's an NRO program for RPKI. It's not just for RPKI, but for many other things. And it is coordinating the RPKI effort between different RIRs. So the goal for this year is to have ASPA support in all RIRs. So some of them probably will need some help, funding, prioritization, etc., etc. So it's hard to say if its goal is going to be actually achieved, but that's what we would like to have. Yeah, and there's some things you can read on that. There's now a RIPE-NCC documentation, and there are official IETF drafts and then examples for that, and even the formal proof of that this verification algorithm is actually doing what we are supposed to have in the end. Yeah, and that was it. So please go if you have any questions or comments, appraisals, accusations.
Any questions? We have a couple of minutes left. Yeah, there are some questions. Please go to the mic. Please state your name, affiliation.
Good morning, Aaron Hughes, Provision. I mean, just one minor comment is that if you're going to be reporting statistics on this going forward, rather than reporting per AS, you should report per prefix, since clearly you create objects based on prefixes and not ASNs.
But how? I mean, ASPA object only has AS customer and a list of AS providers, and it doesn't have anything to do with prefixes.
Aren't these objects only tied to the prefix and not the entire AS? Because you've got different routing policy per prefix?
No, it's completely independent from prefixes. It's just AS numbers. So basically you just encode generally speaking, topology into it, and that's it. So.
Maybe I'm not understanding, and I'll have a read, but I mean, definitely have different prefixes with different AS paths and different routing policy. It's not your whole AS as a single policy.
I would, yeah, but yeah, we can have a conversation about that later. Yeah.
Any other questions? Okay, we have another one. Don't forget to state your name and affiliation first.
Hello, I'm Ulrich from ICANN. I'm in the danger of exposing my ignorance here. In your example with the valley, you had the last AS rejecting the pass. But what is the alternative for the last AS? I mean, they have one provider, so how can they reject the pass?
Yeah, I understand that that's why it's a sort of cartoonish example. So of course, if there's no other ways, you're not supposed to reject the only way through. So of course. Thank you. But yeah, it would be, these slides would get like horribly complicated if we had the actual path that as a workaround there. So.
If there are no more questions, then I'll just thank Misha. Thank you so much for the nice overview.
Thanks.
Next up, we have Thomas Holterbach. I hope I pronounced his last name correctly. Thomas is going to introduce BGP routes, which is sort of a new kid on the block in the world of BGP data collection platforms. And Thomas is going to introduce the project and hopefully explain what makes it different from other existing platforms. Thank you so much.
Okay, can you hear me?
No.
Okay. 1, 2, 3. Okay, very good. Yes, so today I'm going to talk about BGP monitoring, RPKI, LOV, ASPA, BMP, so hopefully quite a lot of exciting stuff. So let's get started. So you probably all know BGP. It's the main interdomain routing protocol used today. And with BGP, it's very critical that we collect BGP data from actual BGP routers, so that then we can monitor BGP. And we have a very good example. Yesterday, we had this presentation by Ștefan and Ioan, and they presented how they design an anycast measurement system. And their system actually heavily relies on BGP data collecting from BGP routers. There are also many other tools like this, which perhaps you are using on a daily basis, and they all use this data. The routers that share their BGP data, they are like our satellites. Each router only sees a little portion of what is actually happening on the BGP ecosystem. And it's when we combine the view of many BGP routers that we can monitor BGP more globally. So it's like satellites. One satellite only sees a small portion of the Earth's surface. And then when we take many, many satellites, then we can monitor Earth's surface more globally. It's the same story. And historically, there are 3 platforms that collect, archive, and publicly share this data. It's RIPRIS, RoadViews, and PCH. You probably know about them. For instance, RIS and RoadViews, they are connected to about 1,500 BGP routers. And we will also call these routers vantage points. So today I am here to present you a new BGP data collection platform that is called bgproutes.io. And we say it's a new platform because we just launched it 1.5 years ago. And perhaps you wonder, why did we decide to build this new BGP data collection platform when there are already RIPRIS, RoadViews that appear to work rather well? Well, we decided to build this new platform because typically when one wants to operate such a platform, there are 2 main objectives. The first objective is that we want to enable high coverage. We want to have data from as many routers as possible, because more data we have, more accurate are our monitoring tools. But in the meantime, we also would like to keep the data for as long as possible, because researchers, for instance, they love to go back in the past, sometimes decades ago, and make some analysis. The problem, though, is that these two objectives, they are not easily compatible. High coverage means we will get a lot of data, but in the meantime, keeping this data forever will then take a lot of resources. So there is a trade-off, and usually what happens here is that we need to prioritize. And typically, RIS and RODUs, what they do is they really put high priority into keeping the data forever. Because again, this is useful, for instance, for researchers. So they keep data for decades now, and this is amazing. But the sacrifice that they somewhat had to do is that they recently transitioned from an open peering policy to a more selective peering policy, meaning not everyone anymore can peer and contribute data to these platforms. Especially if, for instance, you're a hobby network or if you have a redundant feed, then you have less chance to be able to peer with these platforms. And this is fine. That's a good way to deal with this situation. But basically, with BGP-RAS.io, we want to do it the other way around. So we really want to put high priority into coverage. We have an open peering policy. So we really want to get as many feeds as possible. But that also means that we are ready to sacrifice data retention. So we will just keep the data for a few months. And then eventually, when we don't have the resources to keep it, we will just discard it. So our goal here with BGP-RAS.io is to have highly accurate real-time and short-term historical monitoring tools. That's our main goal. Okay, so now I'm going to explain you why you also say that we say this platform is a next-generation BGP ROD collection platform. So first, I'm going to explain you the strategies that we use to hopefully enable high coverage, because this is not so easy. And then I will also explain you how we try to support the latest technology standards, such as LOV and ASPA. And finally, I will also show you how you can better access the data through an API and also some dashboards. Okay, so let's start with how we enable high coverage. So to enable high coverage, we rely on 3 key ingredients. So the first ingredient is automated peering establishment. So what does it mean? It means that if you're in this room and if you operate a network, it's extremely simple to peer with us. It's all automated. You just have to authenticate using your PeeringDB account. And then you just have to fill up a very simple form. It takes 2 minutes. You submit the form. You configure BGP in your router, and that's it. And then you will start contributing data. It's all automated. So thanks to this, today we are connected to about 100 networks already. And every week we get more peers. So this is a good news. However, it's far from being sufficient for monitoring tools, for accurate monitoring tools, sorry. It's far from being sufficient because I will show you a map later, and you will see that there are still a lot of regions in the world with no vantage points at all. But first, let's see now the second ingredient, which is data aggregation. So what does it mean? Data aggregation means that we don't just take the data from our own peers, but we also take all the public data that is available. So all the data that is collected by RIS, ROD views, PCH, and CGTF. CGTF is a small platform in Asia. So we take all this data and we put it into one single repository. So if you go on our website, you can really look at all these vantage points and from which platform they actually come from. So here is the map. So today, if we take all this data, we have about 5,000 vantage points when everything works well. And you can see that there are some regions in the world which do have quite a lot of vantage points, especially in Europe, in North America. So this is great. But again, there are some regions, for instance, in Africa, which clearly lacks vantage points. So that's why also I'm here today, is to try to convince as many of you to share data. When we look at the SEE region, it's pretty okay. There are vantage points, not as many as, for instance, in West Europe, but it's still rather okay. There are still a couple of countries here with no vantage point at all. So again, if you're in these countries, I really invite you to share data. In Serbia, there are 23 vantage points, 1 connected to BGP routes.io, 2 connected to RIPRIS, and 20 to route views. So this is good, but if you think about the number of ASCs that are in Serbia, there are 200 autonomous systems, about 200 in Serbia. So if you take the proportion, it's still a rather tiny fraction. So this is why we, again, need ideally more vantage points, even in Serbia. Okay, so to hopefully get even more data, we have a third ingredient here, which is BMP. So why BMP is useful? Because when we use BGP for monitoring, we are typically wasting a lot of useful information. Why? Because BGP typically only announces the best and non-filter routes. And let's take a little example here. Imagine, for instance, you are IS-123 at the bottom, and you are connected to 2 providers, provider 1 and provider 2, and they each announces the full routing table, so 1.4 million routes. Imagine also that you are connected to an IXP, and you have 1 bilateral session with peer 1, and you're also connected to the route server. So that's a very typical setup. And now if we look at the RIB of IS-123, we will see about 3 million routes in this RIB. That's all the routes that you receive from all your peers. The problem, though, is that now, if you connect to a platform such as BGP routes.io, you're only going to announce the best routes, which are about 1.4 million routes. That means the majority of the routes will not be exported to the measurement platform. And that is really a pity, because you would like to export these routes. You are just not exporting them because BGP does not export these routes. So here, basically, the typical iceberg analogy that I guess we all know works very well. When we use BGP for monitoring, we are only observing the top part of the iceberg, but there is all the bottom part that remains invisible. Is that bad? Well, actually, yes, it's quite bad, because there can be critical information in this invisible part of the iceberg. Typically, if we take the previous example, and you can imagine there is now a hacker that is connected to provider 2, and we can imagine that this hacker hijacks a prefix. Well, this prefix will end up in the RIB of IS-123, but if this hijacked route is a backup path, it's not going to be announced to the collection platform, so we will not be able to detect this hijack. Okay, and that is really a pity, because it's in the RIB, it's just not visible from the collection platform. So this is why we really think BMP can help. We actually think BMP here is even a sort of a game changer. So why? First, because BMP can export all route updates received from every peer. So that means even the backup routes are exported. And aside from that, BMP can also export route updates at every stage of the BGP processing pipeline. So that means we can even export the routes before they are filtered. So that's, for instance, an advantage compared to BGP at pass, for instance. And on top of this, it's also extremely simple to configure. It's just a few lines of configuration in your router, and that's it. So let's take the previous example now. If we imagine that IS-123 is connected to BGP routes.io with BMP, well, literally all the 3 million routes are going to be exported, and we will detect, for instance, the hijack routes. Okay, so today, BGP routes.io has about 37 BMP sessions with 18 different networks. And actually, these numbers, they are not accurate anymore, because this night we had 2 more networks that just connected to us, so we are really happy to see that it's getting more traction. And the previous example that I just illustrated it's not just like a theoretical example. It's really like a concrete use case, a concrete example. Let me show you, for instance, here one case. With EdgeConnect, IS328-365 from South Africa. This is just connected a couple of weeks ago, and it literally exports routes that it receives from all its 465 peers. So it's a couple of BMP sessions, but data for 465 peers. For instance, we get an IPv6 full feed from Hurricane Electric. We get a few feeds from IXP route servers. So here, for instance, the NAP Africa and the INX ZA route servers. And we also had hundreds of feeds from bilateral sessions that EdgeConnect has through these IXPs. So we have dashboards, and you can really see all this data. So for instance, if you go on the Vantage Points Explorer, you can really see the list of all the networks that are connected to BGP routes.io with BMP. EdgeConnect is really the top one. It brings like more than 400 data for more than 400 peers, so that's quite a lot of data. But you can see that there are also other networks that export data for more than 100 peers. So this is quite a lot of data. And then if you click here, what is nice with BMP as well is that we really know from which peer the data comes from. So for instance, here we know which data come from the INX ZA route server, which data comes from the NAP Africa route server, and so on and so forth. So then you can even click here and really see the raw data if you're interested. It's all publicly available. Okay, so now I will move to the security part of the presentation because I guess you are all interested into security and BGP. So let's see how we deal with this. So every time BGP routes.io collects a route, it tags the route with its LPKI LOV and ASPA status at the time we receive the route. For LPKI LOV, it's pretty straightforward. I guess we all know how it works. We just want to validate the origin in the ASPAs. So here, the outcome can be either valid, invalid, or unknown. That's pretty simple. For ASPA, it's a little bit more complicated. Well, the good news is that we just had an ASPA presentation before, so we are all expert now. That's great. So ASPA, just a little reminder, it's to prevent, for instance, value-free violations, so typically route leaks. And it's a little bit more complicated here because there are two algorithms that can be used to validate an ISPAS using ASPA. There is an algorithm that needs to be used when it's a downstream ISPAS, so when the path is received from a customer, a peer, or a route server. And there is another algorithm that is used when it's a downstream ISPAS, so when the path is received from a provider. And the problem with BGP routes.io is that we don't really have customers, peers, or providers. Okay, we are just a collection platform. We don't have, for instance, a business relationship with IS-123. So we don't know which algorithm we should use when we receive a route. Yes, we could try to infer, the relationships between, for instance, the providers here and IS-123. We could try to infer that they are providers, but it's always probabilistic, so we cannot be sure that, in fact, they are providers. Maybe they are actually peers. So it's not so simple. So what we do in this case, we just run the two algorithms, and we just tag the route with the two outcomes. So here, for instance, each route, we have the results of the upstream algorithm and the result of the downstream algorithm. In each case, it can be valid, invalid, unknown. And then we let the user decide which algorithm they want to use to validate the route. Okay, so now I'm going to explain you how you can use this data. Yeah, this is important because collecting more data, it's great, but it's not so useful when users, they are not equipped with the tools to effectively process and analyze this data. Typically what happens is that there are these MRT archives which contain tons of MRT files which are compressed, and in these files everything is mixed up. So it's very hard to actually process these files, and it takes a lot of time and resources. So yes, we do store the data in an MRT archive, but it's not really the way we recommend to use the data. Instead, what we did is we designed an API that is simple, fast, and can provide high granularity access to the data. Okay, so the API offers 4 endpoints: vantage points, updates, RIB, and topology. And each of these endpoints, they also have a set of parameters, so you can really build flexible queries. And the goal is that you never have to download and process a huge volume of data that most of it is just irrelevant, but you can just get the slice of the data that matters for your analysis, so it makes everything much faster. Let's take a little example. So imagine you're a network operator and you want to try to get all the BGP updates for which your ASN is in the ASPA today, for instance. Well, if you do this with MRT files, you would have to download, again, a lot of MRT files and process a lot of data. So here instead, what you can do with the API, you can just use our Python client, which is called PyBGP routes API. You import the vantage points and the updates function. And then you use the vantage points function to get the vantage points that you want. For instance, maybe you want all the vantage points from BGP routes.io and RIPRIS. And then you just iterate over these vantage points. And for each of them, you use the updates function to get all the updates collected by these vantage points and which are collected within the given time frame. And then you can also use ASPA's regular expression to just get the updates that match these regular expressions. So here, for instance, we assume we are IS3, so we will only get the updates with FLI in the ASPAs. Okay, so that's typically an example of what you could see if you run this little code. So you could get 4 updates only, and all of them, for instance, in the ASPA, they contain IS3. And that's it. You will just get these 4 updates. So it's going to be extremely fast. So as I was saying before, the API also returns the RPKI LOV and ASPA status. So alongside the time, the prefix, the ASPA, and the community values, you will also have the LOV status and the ASPA status. And that is actually pretty useful because now we can make analysis about the deployment of LOV, the deployment of ASPA, for instance, and we can also detect route leaks using this API. And that is actually what we did recently, so I will show you this. So for instance, in this code snippet here, you can use the LOV status, and you can say, okay, I just want the updates which has a LOV status equal to invalid or unknown. And then you can also say, I want the ASPA status, I want all the updates with an ASPA status equal to down invalid or down unknown. And then you will just get, for instance, here the first and the last updates because they match these criteria. And the 2 updates in the middle, they are not going to be returned by the API. Okay, so yes, as I was saying, we can do some measurement studies now. What we did here is we wanted to analyze ASPA for downstream ASPAs. And for that, we just took all the data we collected during a 2 hours time frame. We found that 99.3% are actually ASPA unknown. That's sort of expected because today there are not so many ASPA objects yet. So most of the ASPAs we just don't know. But we also found 0.04% of the ASPAs that are actually invalid. So it's just 0.04%, but this actually translates into hundreds, even thousands of ASPAs. So all of these ASPAs, they are possibly, very likely, actually route leaks. And finally, we found that 0.7% of the ASPAs, they are valid. Most of them are actually pretty short ASPAs, because shorter is an ASPAS, more likely it is to be valid. But these are interesting results, and now what is nice probably is to redo this experiment every month, every year, and hopefully we will see more valid ASPAs and less invalid ASPAs, but let's see. Okay, so finally, if you don't want to program by yourself, we also have a set of dashboards that you can use. We have an IS Explorer where you can see details about the autonomous systems. We have a Prefix Explorer, which is like a giant looking glass. We have a Vantage Point Explorer, which I just showed you before. You can navigate through all these Vantage Points. We have IS Rank as well. And for all these dashboards, we are really using all the data we collect, and we are using this data to maintain these dashboards and make them as accurate as possible. So I really invite you to go and check them out if you're interested. But that basically ends my presentation. So if you like the project, if you would like to contribute, you can definitely scan this QR code and then fill up the form, and then you will start contributing data. The data is publicly available. Everyone can access it. The API is public as well. And finally, also, I just want to thank you, the sponsors that we have, so the APNIC Foundation and OVH Cloud. And that's it for me. Thank you very much.
Thanks, Thomas. Any questions for him? We have a couple of minutes. Vlad, please.
One comment and one question, or
Name
one
and affiliation.
recommendation. Vladislav Bidikov, Faculty of Computer Science Engineering. First, we'll fix the Macedonian black thing probably today.
Cool.
And now the question/recommendation. It would be very nice if in the future you could think about how actually you can use the API for some stuff without trying to think about it from the zero. For example, a small snippet, or how you can actually get the API and get some stuff monitored for yourself or something, because that will help then people consuming data.
Yeah, you mean something to help users to use the API, or sort of a documentation. Yeah, so it's, by the way, it's already documented, but I can understand that it's still hard to use from like a random person. So we are actually working into this. Hopefully, maybe in the coming months, we will have like a tool that is more like automated, you know, so you don't have to program anymore. Yeah, so that's a good feedback.
More questions? 1, 2, 3. If not, thank you, Thomas, again, and good luck with the project.
Now it's time for lightning talks. Now, next we have Slobodan Mitrović. He will explain us how to have cheap and affordable LAN automation using the AI, of course. So, the floor is yours.
Hello, everyone. And I would like to talk to you about our way to implement the AI on local large language model into the process of LAN automation. So, okay, thank you very much. Okay, so, okay, well, our way started recently, several months ago actually, when we tried to implement neural network within the task of reconfiguration of some devices. Particular task was related with traffic shaping and change of their parameters. And after that, we ask ourselves, what if we use large language model instead of neural networks within our configuration? So we have several motivations for that. Many of them are operational, and we have educational motivation as well. the main point is to build an engine which could be packed in some local machine and deployed at certain part of local network with certain document base and reasoning based on that. We don't want a fully online tool just like Claude or ChatGPT or etc. We just want to be locally based. And in order to do that, we had some already configured ingredients that should be configured. We have syslog servers, syslog data, SNMP data, which are obtained via MRTG, Elasticsearch for data systematization and reconfiguration in order to be graphically presented by Grafana. We also have NetMiko, you know that tool for configuring devices using net scripts. And at the first moment, we have neural networks, which are excluded from the model. And later, we included LLM with reg configuration, Streamlit user interface for as a chat interface, ChromaDB as a kind of standard, one of standard databases for knowledge base, and of course CLI documentation with for certain vendors. In this case, we used our testbed, some kind of hardware, one Cisco SA router, two Cisco Catalyst switches, one server which was the host of two virtual machines. One is machine with syslog server, Elasticsearch, and Grafana. The other one is actually we started with that virtual machine with Mistral 7B, large language model, Streamlit UI, ChromaDB, PyPDF, LangChain, and text parser as well. So we got the first result. We have one simple test, and that was the test is contained in configuring two VLANs. One is the actually three VLANs, but two VLANs were used for assigning Ethernet ports. One was the so-called management VLAN, and we assigned ID 51, and the other one is so-called user VLAN with so-called with ID 52. And we, when we made response, how many ports are in management VLAN, we got response that there are 10 Ethernet ports assigned in access mode, but also, which is correct, that is correct, but we also get the response that there is another 10 ports assigned to another VLAN. That is the answer we don't need. We don't need it at the moment. So this kind of response is acceptable. Now, what happened? The generation of that response was extremely slow. Actually, the best result we achieved is about 200 seconds. It lasts with virtual machine almost 3 or more 100 seconds in some cases. However, we need to replace that with real machine, with Ryzen 7 processor, 33 gigs of RAM, RTX 3016, and we got much better result, very acceptable with response time 5 to 7 seconds, depending on what was the prompt. The other kind of task was related with Elasticsearch and Grafana, and we just kept some kind of initial configurations. That is actually task that we have to do because we would like to assess actually new OpenSUSE distribution, LIP16, that actually integrates Elasticsearch in default configuration. We didn't assess that yet. We would like to do that, and so we left this as kind of to-do tasks. All in all, we have some preliminary results. We can be satisfied with that, but there are a lot of things to do in order to make this thing ready for a kind of automation. We are not recommend fully automation, and because it is too risky, because there is a possibility of hallucination. It depends on what data source we use, how the quality of that text is, but rather at this point we would like to use this kind of solution as a smart assessment tool or copilot, call it whatever you want, and also we would like to advise still things. Don't use virtual machines for LLM model. It is too slow, definitely. And the other one, if you need to learn the machine for certain scenarios, please use prepared document. Just ask yourself what should be the prompt or the question, and what should be the answer of that question, and prepare the document in that way. So, okay, that would be all. Okay, thank you. Any questions? How much time?
Okay, do you have some questions? Please don't forget to state your name and affiliation, please.
Hi, I'm Sara Djurdjevic from Unit International. My question is, I didn't understand, is this automation more like help to analyze something in the network, or do you want to use it to actually configure the network or the routers?
Yes, it is, our intention is to make it to analyze logs and to make responses on that using NetMiko tool.
Okay, thank
for
you.
that.
And one more question, if I may. Also, do you think this is going to, in the future, of course, because it's still in production, do you think this is going to make the need for engineers a bit lower, or are you still trying to provide this as a tool for the engineers themselves? Because if you're analyzing something, you expect the person who's looking at the data to know what they're looking at. But now in the era of AI, where everything is automated, people tend to rely on the AI too much and not on the engineers anymore. So,
well, our primary motivation is to make assistant tool for our junior technicians, which are not completed all courses for that they need for their job. And on the other hand, we would like to show the solution to our students, which are actually not trained at all. So that is the basic motivation for that. And okay, yes, we could use fully online tool, but somehow we think that is too risky. Especially if you would like to use it for some sensitive kind of networks that there is no room for mistakes or there is no place for any data leak. So, okay, that was our actual intention at the moment.
Thank you.
We don't know what will we do actually when we got some further results.
Okay. Thank you very much.
Okay, you're welcome.
So next we have Ștefan, Alexandru, Cezar, Mincu, and he will tell us a story about how a networking club gradually evolved from a small student initiative to a real experience with real infrastructure and real constraints.
So, hi everyone, I'm Ștefan Mincu, a student from Alexandru and Cuza Theoretical High School in Bucharest. So I'm going to start with a simple question. Did you turn your personal interest into something real? Because for me, it was what I started with. At that time, I was already experimenting a lot. I just registered my ISN and I just received my IPv6 allocation. So I experiment a lot, but just individually. At the same time, I went to a new high school. So I've noticed something. Can I turn my passion into something real? That was my question that makes me do something. So I identify a problem at high school. So the computer science is most likely focused on programming, and students are rarely get exposed to networking unless they are actively searching for it. Even if there are a lot of information online, they are easy to get lost, and the students rarely get with hands-on experience. So they might just use packet tracer or GNS3, which it's very useful, but at some point you need to get hands-on on a real equipment. So I decided to start a club. I was already doing networking on my own. So I saw the interest from students. I asked some of my classmates if they are interested in that. So I started as just an idea. Then I wrote a document to the school management to show them why this club will be important, what we want to do. And they surprisingly approved the project. After that, I found a teacher who supports the initiative, and a few colleagues, a small group of colleagues that wants to help. So we structured the club in a simple way. We started with a short introduction, theoretical part, followed by a practical lab session. And after that, we do a quiz to see what they actually learn and if they have some things that they didn't get it from our theoretical introduction. We re-explain it to make sure that they learn something from us. So after that, we collect the feedback to improve things step by step after each session. So after that, we wanted to create something more real, and we started to build a mini infrastructure inside our high school. It was very hard because at the starting point, we don't have so many resources. We had one older server, my IPv6 allocation, and basically no connectivity. And with the support from our NREN ROE.net, we managed to get a fiber connection. However, shortly after that, our high school entered in a full renovation, and we don't manage to use it. We also preparing to a new network setup. At the beginning, it was only for the networking club because we want to make sure that it was a secure network and it works in right parameters. And after we think to expand it to all the students and the high school as well. So we faced many challenges along the way. No stable funding, equipment limitation, learning how to ask for support. High school being in a full renovation, we don't have any more space where we can make those sessions, and we think what we do after my graduation, how the networking club will continue. So the key things I've learned, it's building something for others, make you take it seriously, and asking for help, it's part of building something real, and even a small project can create a real impact. And the last but not least, and I think the most important, it's you don't need a perfect condition to start something that it's meaningful for others. So in conclusion, not everything went as planned, but the community support make a difference. And this experience showed me that networking is not just the technical part, but also the community. And I'm really glad to have those experience. Thank you.
Okay, it's time for questions.
Hi, my name is Ulka Atle, and I work for the RIPE NCC. Ștefan, thank you for your talk. I have a question. Since you are now standing in front of the community, and you said community support makes a difference, what kind of support would you have wanted for your networking club?
So for the networking club, for the community which are not based in Romania, they can maybe provide us some materials that we can share with other students in high school, or from local community from Romania, they just can support us with a space where we can make those sessions. And as well, the materials will be very nice, or equipment. And that's basically what, and some feedback as well, as suggestions and other things.
Thank you.
Thank you.
And maybe some IPv4 space. Okay, thank you very much, Ioan. So, next we have Vladimir Vuković with documentation trap, turning fiber maps into operational data. Some lessons from QGIS and FiberQ workflows.
Hi everyone. I know lunch is next on the agenda, so I'm trying to keep it short here. Maybe this topic is not post-related to network, but without fiber optics, we will not have the option to communicate. So I want to present a little something what I do day to day in Telekom Serbia. Thank you, RIPE organization, for opportunity to present today. My name is Vladimir Vuković. I work at Telekom Serbia. In my spare time, I develop the FiberQ plugin in QGIS. That's basically the plugin that it's free and open source tool for fiber optic infrastructure documentation. And today I want to show you what separates usable fiber documentation from documentation that looks fine but breaks the moments that someone else need to use it, when practically you hand over to someone and he basically don't understand, or he needs your help to solve some problems. I will show you a bad and good example side by side, and then a few practical rules anyone can apply. So here on the left side, we can see manual labels only. This left side is illustrated picture. So we have manual labels only, no stable IDs on the map for elements, cables, routes, ducts, no obvious start-end logic for cables or ducts, looks completely visual, but weak for tracing and handover. And on the right side, in QGIS, it's example of stable IDs shown for cables and key point assets. Same geometry, but relationships are explicit and readable between elements. And operational tasks like tracing and validation become possible. Also, maybe not bad to add option when you can hover your mouse on the lines, so you can see multiple lines elements like routes, ducts, and cables to see how many of them are there on that line, and maybe to add offset buttons so you can separate those cables side by side, so you can see it clearly. So two maps may look equally convincing, only one is usable after handover. I'm gonna point next to the next slide. That's mainly point elements. You can see on the left side, bad example how generic names such as pole, box, or closure, they don't have IDs, no type distinguishing or duplicates labels in the same area. Operators must guess which object is which. And on the right side, we have a clean example. Okay. We have a clean example such as IDs such as pole, PL for pole, MH for manhole, OTB for all optical terminal box, joint closures, and stuff like that. Consistent naming by assets type and object class. Also, to every element should be defined as a unique icon, so you can easily recognize that on the map. Clear labels make field verification and maintains easier for engineers and for technicians. The same principle applies to the lines. Routes, ducts, and cables each need their own ID, not just the fiber count label. We are moving to the next slide. This is mainly the important one. So you can see on the left side, objects appear close, but dataset doesn't prove they're linked. Tracing depends on memory, manual notes, or guess over, what is what, which is which. Handover becomes fragile because the logic is implicit. And on the right side, you have cable, duct, and assets links are visible as data, not as assumption. So you can have a query relationship, how maybe one cable is connected to between two elements. Start and containment relationships are easy to verify. The map becomes a network model, not only a picture. And this is something easy that you can add on your software. I know how complicated it can be when you have multiple cables from different relationships on the map, so you don't know what element belongs to which cable and which cable belongs to maybe some joint closures. You can select a relationship name to highlight the full cable on the map. So you can select by some Alt-A and cluster 1, so you can select those, and in different color you will display that path from point A to point B. Multiple cables from different OLs can share the same physical route. Each cable path is color-coded, so overlapping paths stay distinguishable. And you can add maybe some option to offset also those lines, so you can easily separate cables on the map. Selecting one relationship highlights only that cable, no manual tracing, so it's easier for engineers and technicians to guess what cable they need to maybe investigate or to do some on that cable. This only works when relationships are stored as structured data. And when relationships exist as data, tracing a cable path from old to endpoint becomes just simply one click. Next is layer. This is the quick one. On the left side, you can see it generated picture. Too many mixed purpose layers or unclear names. Symbology hides the difference between assets types, and ending and validation becomes error prone. And on the right side, we have a clean example from the FiberQ plugin. Layer groups follow assets, classes, and workflow logic. Symbology helps the audience understand the model quickly, so you can easily turn off or turn on the layer, so you can easily recognize that what you need on the map. The same data set is easier to maintain over time. So each project should have this example of layers. Clear layers reduce mistakes before anyone can even open the attribute table. And we have here some attribute table. That's the good side of the QGIS. It's not hard-coded. Mainly corporate softwares, when you put some information about some elements, they are mainly hard-coded, so you cannot add or remove some stuff that you you don't want to need that. And if you want something, you cannot simply. You need to ask them to update that software. So that's why QGIS, it's open source. It's easy to manipulate with attribute tables. On the left side is illustrated picture. The map look completely while the table is almost empty. Free text values makes export and reporting unreliable, and most operational depth starts here. So when you hand over some documentation, the engineers and technicians do not understand what or which element is which. On the right side, I don't know, you can see clearly the screenshot. The attribute tables carries the real structure of the network. That's example from one cable. IDs, naming, domains, and the relationship field support handover. Maps, reports, and validation all becomes more reliable. And in the bottom of the attribute table, you have from to, so you can easily guess from what element that cable begins and in which elements it's ending. A clean map with weak table is still weak documentation. Same goes for the point elements, missing IDs, repeated names for different assets, too few fields to support maintains or inventory. And on the right side, you have a stable IDs, type field, status, and ownership or location logic. That's an example from one manhole that we inputted in FiberQ. Table support field work, export, and quality checks, so you can easily understand that manhole when you open in your documentation. So 4 design rules for usable fiber documentation is to have a persistent IDs. So every cable, closure, splitter, and endpoint elements needs stable references. Map labels may change. Object identity must not. So, and as I was saying before, you will need for each element to have a unique icon style on the map, so you can easily recognize that elements on the map, so you can easily understand them and find them. Control names and domains, mainly engineers put manual stuff inside of, and they not use hierarchy correct, so they simply put maybe John closures 1, they not follow the rules. So use standard naming patterns, pick list, and limited free text. If naming is unpredictable, search and validation break first after handover. And explicit relationships, that's what I was talking about, the relationship of the cables, record start end, containment, severing point, and splice logic as data. So that's another topic not in this presentation for splicing. And geometry alone is not a network model. One data set, many outputs. The same structure should support design, handover as built and schematic, so you can easily recognize and you can manage to use it over time. Parallel spreadsheets created drift and hidden operational depth. And good documentation is a design decision, not a cleanup step at the end. Minimal QGIS workflow. Okay, I'm on time. You need to define assets layers, cable ducts, point assets, service areas, and base IDs. Build control forms, how documentation should be projected and hand over to some company. naming patterns, required fields, and simple value list, or ask that company how are they using their control forms, so you can adapt to their control forms, and capture relationships, start end links, containment, service logic, and splice references for the cables from two elements, run validation checks, missing IDs, broken links, duplicate names, and empty required fields. You can easily add some maybe option in your software where you can run validation check if you have duplicated IDs or elements, and you can easily correct them, and publish outpost as clean maps, tables, and hand overviews from same dataset. So you do not need a heavy system start, you need a consistent instruction from day one, and many engineers have that problem when they get documentation from constructor. The goal is not prettier maps, the goal is documentation that operations can trust on day one. And 3 takeaways: ID's naming and the relationship must exist before, not after it, because the engineer cannot understand that. And QGIS can support this with a simple repeatable data model and form logic. And better structure now means less operational depth later. So it's much better to hand over the clean version than a dirty one, and you lost many times, many hours to correct those. And that's it. If anyone have questions,
Thank you. Applause, please. Do we have questions? Okay, thank you very much.
Thank you very much.